Hello and welcome to Microchip's Memory Technology series. So what is hot electron injection? Hot electron injection is a physical event that we take advantage of to program or capture electrons on a floating gate in integrated circuits. Any IC that has a flash or superflash non-volatile memory inside, that's microcontrollers, microprocessors, or standalone memory integrated circuits, take advantage of this hot electron injection process to program logic zeros into your memory. Now the word hot here has nothing to do with temperature. The scientists that discovered this phenomena used the term hot just to describe electrons that build up enough kinetic energy inside a high electric field to jump or burrow or tunnel, use your favorite verb here, across an oxide insulator. Let's do this with pictures. Here is what a flash memory cell looks like on paper. This is the gate symbol and this is a cross-section drawing. And over here is a superflash flash memory bit. Both use hot electron injection to program or write the cell, so let's look at both. Inside the IC, we have a charge pump to create the high voltage we'll need to program and erase these memory bits. So let's say you supply a VDD of 1.8 volts to your part. So inside, we create, well, let's say 10 volts from that. This 10 volts will give us a big enough energy field to create the kinetic energy we will need to get some electrons hot enough to jump across this oxide. Here are the voltages we'll apply to get our hot electron activity. Note that because of this two-level gate structure, superflash can use lower voltages than standard flash to get this to happen. And as you see, we have the current running through the transistor in the other direction. If you want to understand why that makes superflash a better flash memory for your application, then watch some of our other videos. For now, just trust me. So the gate is turned on and the electrons flow through the transistor. Because of this high voltage up here, all electrons crossing the channel are seeing lots of electric field pulling them up. And some electrons will gain enough energy at just the right point to tunnel through this very thin oxide. These electrons are actually trying to reach this high voltage, and maybe some will, but many will lose enough of their energy on the journey to get trapped on this floating gate. After a fixed amount of time, check your targeted data sheet for that time, because it can vary based on what the IC maker is targeting for applications. Anyway, we will have enough trapped electrons that we can turn off the high voltage. One final note on this, hot electron injection, these electrons being pulled through this oxide, is hard on the oxide and it will damage it eventually. The newest NAND flash technologies will let you erase and rewrite your memory maybe 1,000 times. NOR flash data sheets promise between 10,000 to 100,000 hot electron rewrites per cell before you may break the part and make the memory worthless. Superflash always promises 100,000 minimum. Now we can run the memory back down at 1.8 volts to read the results. Notice the change in voltages. These lower voltages will cause no stress on these oxides, so you can read your memory forever, as many times as you want, and not damage these cells any further. Again, that's for reads. And once programmed, the memory can be turned off. You can unplug it from the battery or the wall, and the content is not lost. You can come back in 20 years, turn the power on again, and your memory content, all your precious ones and zeros, will still be there for you. The cells we wanted to write or program as a logic 1 just never had the 10 volts applied, so they don't have trapped electrons. When read, those will allow a current to flow through the memory cell, which will be interpreted as a logic 1, just as we wanted. These others did see the 10 volts, so they have trapped electrons. Those trapped electrons will block the gate voltage enough to prevent current from flowing through the transistor, and that lack of current will be read correctly as a logic 0. See our other videos to learn more details about double EEPROM, NOR flash, and some other memory technologies.